All right, so we're going to talk about Chapter 2, Section 1, which deals with the use the language. Let me see if I can get my handwriting here better. Use the language of algebra. So what we're going to start doing here is we're going to start building a foundation that we're going to use from now until you are done basically with mathematics. So what I want to start off with is just identifying the differences between variable terms and constant terms. So a variable term is basically what it sounds like. Okay, so a variable term is a term that contains a coefficient and a variable. All right, and I think this pen is a little too thick, so I'm going to go down one size. Now, examples of a variable term would look something like this. Like you can have the variable x, completely 100% variable term. Also, you can have something that looks like this, 3x, okay? Or you can have x times y, which are just two different variables. So now that we've identified the variable, let me show you where the coefficients are. So the coefficient is going to be the number that is attached to the variable, and it's being multiplied by it. So for example, in the first, even though we write x, it's really 1 times x. In the second example, that 3 is going to be the coefficient. And then in the last example, you have 1 times x times y. The thing to remember, though, is just that the coefficient is the number that is being multiplied to the variable. And like I said, sometimes you could write a 1, but you really don't have to. So there's our first definition. Our second definition is going to be a constant term. So a constant term is strictly a number. Okay? So examples of that would be something like 5, 10, 2021, whatever. The thing is, they're numbers. There's no variable attached to it. So please do not assume that, numbers are constants or numbers are coefficients. They fit different roles. A coefficient, like I said earlier up above, a coefficient such as 3 times x is the number that is being multiplied by the variable. A constant never changes. It's always going to be the number 5 or the number 10. Okay? So the next thing I want to do is go over different symbols that we use within algebra. Now, one of the symbols you're extremely familiar with is going to be the equal sign. Okay? But some other symbols that you might not be aware of are called inequalities. All right? So what I'm going to do is I'm going to write them and then I'm going to group them all together. Okay? So inequalities, let me write it off to the right. Inequalities are read left to right, and we use them to form true statements. Okay? So here are the inequality symbols. The first one is that symbol, and it means less than. Having a problem writing today. I don't know why. The second inequality is going to be less than or equal to. Now, the third inequality, I'm going to skip a space, is greater than. And then the last one is going to be greater than or equal to. And remember, we read them left to right, and our goal is to form true statements. Now, there is another inequality symbol that we do use. In fact, we use it a lot. But I don't think we do a good job at kind of explaining it, and that's this one, which stands for not equal to. And we use this a lot when we're comparing numbers, or we're comparing quantities or something like that. Okay? So real quick, I'm just going to go over just a couple examples. All I want to do is translate from an algebraic expression into words. Okay? So like here's an example right here. 15 is greater than or equal to 7. So to write this, we would just write 15 is greater than or equal to 7. It's pretty straightforward. Here's another one. Maybe we'll go 3 is less than 10. So now I'm going from a statement into an algebraic expression. So I'm going to write 3 less than 10. Okay? And if we wanted to, what we can do now is we can actually start to compare numbers. So for example, using inequality signs or using inequalities, form a true statement. So what I'm asking you to do here is just look at two numbers and then put something in this box so that when we read it from left to right, so when we go from left to right, it forms a true statement. So in this case, 17 is less than 34. And that's basically it. So now we're going to talk about common grouping symbols. Now, there are things that we do in math where we have an order, if you will. Okay? So what's nice about that is the fact that when you approach a problem, okay, and it doesn't have to be an equation. In fact, we're not going to see equations until the very end of this chapter, all right? But when we approach something and the directions say simplify or the directions may say solve, the goal here is to figure out a systematic approach on how to do that, like a recipe, if you will. So we always start off with the grouping symbols first. Now, we write grouping symbols in different ways. So, for example, we have parentheses, okay? That's the first type of grouping symbol. The second type of grouping symbol are just brackets. And then the last type of grouping symbol are going to be braces, okay? Now, the reason why we use 3 different types of grouping symbols is to honestly keep us in check in terms of where things match up with other things. For example, off to the right, if I wrote something like this, okay, that looks very messy. However, if I change this up and just wrote it like this, now you can see that anytime we open a parenthesis, we close it. Anytime we open a bracket, we close it. Anytime we open a brace, we close it. So these common grouping symbols are just for notation. It's to help our eyes focus on where in the problem that we want to look at. That's it. Okay? So now we're going to turn our attention onto an extremely important concept. And to be honest with you, students always kind of have trouble with this. And I think it's because maybe in the past, we just weren't good enough at explaining the difference. So, first thing I'm going to talk about is an algebraic expression. Okay? Now, an algebraic expression is a mathematical statement. Okay, it's a statement. It'll always contain at least one of the following. Okay, here's the first thing. It will contain a variable term. So we know what that is. We already defined that earlier. Second, it can contain a constant term. And we've already established what that is. And lastly, it will contain math operations. Okay? Now, some examples of what algebraic expressions look like are this. 3 plus 2. It's an algebraic expression. It contains an operation, which is a plus sign, and it contains two constant terms, 3 and 2. Okay? Here's another one. In this case, it looks a little complicated. We have x plus 1 in the numerator, and then downstairs in the denominator we have a 3. But this is read x plus 1 divided by 3. But once again, this is a algebraic expression because it contains a variable term, constant terms, math operations, a plus and division. Doesn't matter though. It is it's an algebraic expression. Okay? Now, an equation occurs when you have two expressions, which we just defined, equal to each other. Okay? In other words, you have an expression on the left side equal to an expression on the right side. This equal sign separates the left and the right sides. Okay? So notice with an equation, and I'm going to zoom out here a little bit so you can see algebraic expression, the word, because I think it's really important right now. So notice with an equation, you have sides. You have a left side, you have a right side, okay? Oh, I hate when that happens. That's all right, though. We adapt. So with an equation, you have an expression on the left and an expression on the right. With an algebraic expression, there are no sides, okay? There's no left or right side. It's just a statement. That's it. In fact, the directions for everything on here are completely different. For an algebraic expression, the directions will always say simplify. And I know we've heard that before. We've heard that word before. With an equation, the directions will always say solve. So two completely different things here. And like I said, sometimes I think students tend to just mix these up a little bit. Expressions, no sides, variable term, constant term, math operation. Equation is when you have two expressions with an equal sign in between them. Okay? The next thing I'm going to talk about are going to be exponents. Okay, so exponents are just a really fancy way of writing multiplication over and over again. Okay? So, for example here, I'm going to write 2 to the 5th power. And that's how I read this. So I'm going to write that 2 to the 5th power. Forgot a T in there. 2 to the 5th power. Okay? And what this means is 2 to the 5th. We can rewrite that as 2 times 2 times 2 times 2 times 2. So what you're doing is you're taking what we call the base, that's the number 2, and you're going to multiply it by itself 5 times according to the exponent. So remember, when you have a number that contains an exponent, The base is going to be the big number that you write like on your page. And then in the upper right-hand corner, a little small number, that's called the exponent. And that exponent says, multiply the base this many times. That's all it says. Now, if we wanted to, we can actually simplify this. 2 to the 5th power equals 32. I'll let you figure that one out. I'm just going to write the answer, okay? But that's what an exponent is. So what I'm doing here is I'm starting to set you up for something, okay? Excuse me. Because if you notice, and I'm going to scroll back up here, I talked about grouping symbols. All right. I talked about algebraic expressions. We briefly discussed an equation, which we're going to see later. And now I'm talking to you about exponents. At the beginning of this lesson, I said, math is really nice because there's like a recipe to do things. And what we're talking about now is that recipe, okay? So, for example, if I asked you to simplify this expression here, okay? If I ask you to simplify this expression, and this is read the quantity of 12 minus 5 times 2. A natural question would be, well, where do I start? And that's the recipe that we need. So what I'm gonna define for you here. Actually, let me write the sentence here. In order to simplify, we need and this is the biggie here. Order of operations. The order meaning this is what you do first, is what you do second. Operations, add, subtract, multiply, and divide. Okay? So there is an order, and some of you may have already known this. I'm going to say something, and I never ever want you to repeat it again because I don't like it, but I'm going to say it anyways. Some of us may have heard of this, please excuse my dear Aunt Sally thing. And I'm just going to write the statement real quick. Please excuse my dear Aunt Sally. And I got to be honest with you, I absolutely hate this. And here's why. We'll come back to the problem on the top of the screen, the quantity of 12 minus 5 times 2. I want to go over this order of operation thing and this please excuse my dear Aunt Sally thing because it just drives me crazy. So if I gave you this problem right here, what I'd like you to do is I'd like you to pause the video, do this problem, and then unpause it to see if you got the correct answer. So I'm going to go ahead and do this problem, but what I want you to do is pause. Okay, so if you pause the video and you're coming back, if you got 1 as an answer, you would be incorrect. Okay, 1 is not the answer to this problem. The correct answer is 4. This is the correct answer. Now, here's why I hate the dear Aunt Sally thing. When we do our order of operations, okay, and I'm going to write mine like this off to the right-hand side. This is how I like to write it. I write it in a stacked form, and the P stands for parentheses. Okay, and what we mean by that is we really mean all grouping symbols. So you're going to do whatever math operation that's located inside parentheses, brackets, braces, and you're always going to look for the innermost, okay? So I'm going to put innermost here. And don't worry, I'll show you an example where that kicks in. Now, the second thing you do is going to be exponents. So if you see any exponents, you want to simplify that, all right? And hopefully you can see that parentheses is first, it's on the top line. Exponents is second, it's on the second line. Now, here comes the part where this is where students always, they tend to go wrong here. Multiplication division is on the same line, which means they share equal priority. However, you're going to do multiplication or division from left to right in order. Because multiplication and division both have equal priority. One isn't more important than the other. It's you do them from left to right in the order that you see them. And the same applies for addition or subtraction. You do them from left to right in order. So if I go over and I look at the 16 divided by 8 times 2 problem that I have, well, I don't have parentheses, I don't have exponents, but I do have multiplication and division, which means I need to do them from left to right in the order that I see them. So I need to do 16 divided by 8 first, and that simplifies down into 2. Now I'm going to drop down the multiplication symbol and the second 2. And then from here, I read it again. 2 times 2 is 4. And that is how we simplify every single problem. You will follow this order of operations, okay? Where parentheses and grouping symbols are first. Always do the innermost. Second is going to be exponents. Multiplication, division. Equal priority goes from left to right in order. Addition and subtraction. Equal priority goes from left to right in order. So now, if we go back to our problem, the quantity of 12 minus 5 times 2, well, on the right-hand side, I just write my little order of operations, and I just go right down a list. Do I see parentheses? Absolutely. So I'm going to do the math inside. Now, when I look inside, I start following my order of operations. I don't see any exponents inside the parentheses. I do not see multiplication nor division inside the parentheses. I'm going to just I'm going to subtract these two numbers. 12 minus 5. It's going to be 7. Then I drop down the times 2. 7 times 2 is 14. Okay? And that is how we simplify problems. So what I'm going to do here is I'm going to go ahead and start simplifying problems. And it may seem like I'm going a little fast. What's nice about the video is you can always pause it, and then you can just come back and watch it again. Okay, so here's our second example. $12 times 3 divided by 4. So I'm going to go ahead and just apply my order of operations. I do not see parentheses. I do not see exponents. But I do see multiplication, division. So I'm going to do it from left to right in the order they appear. So 12 times 3 is 36. Divided by 4. 36 divided by 4 is 9. And no more multiplication, division, and I definitely do not have any addition or subtraction, so I'm done, which is a fantastic thing. Now, the problems are just going to get a little bit more complicated, meaning there's going to be more numbers, okay? So here's an example here. 30 divided by 5 plus 10 times the quantity, 3 minus 2. On the right-hand side, I'm just going to write out my order of operations. And I do one step at a time. I don't combine things. When you get better at this and you start to see, like, maybe 1 or 2 steps ahead, then you can go in and start doing that. But for now, we are just going to keep it simple. So, do I see parentheses? The answer is yes, which means I need to subtract 3 minus 2. I rewrite everything exactly how it looks, except 3 minus 2 is going to be a 1. Now, parentheses are over. I do not see any exponents, so I could scratch that out. Now I'm going to do multiplication and division from left to right in the order they appear. 30 divided by 5 is 6. Plus 10 times 1. Remember, I do one step at a time. Now I need to multiply 10 times 1, so that's going to be 6 plus 10. Multiplication division is now complete. Lastly, 6 plus 10 is 16. Okay? From here, I'm going to just do a little bit more complicated. We're going to see some exponents. So I write my order of operations. And I just go right down a list. Do I see parentheses? Yes. I need to do 3 plus 2. So I rewrite everything exactly how it looks. 3 plus 2 is 5. So I can scratch it out. Now I need to do exponents second. That's the very first value, 4 to the second power. So 4 to the second power, remember, I'll write it off to the right. That means 4 times 4, which equals 16. It is not 8. Okay? So we get 16 plus 2 times 5. Now my exponents are taken care of. Multiplication or division. So I'm going to have to multiply 2 times 5. That's going to be 10. And then lastly, add or subtract. I'm going to add 16 plus 10 to give me 26. We're going to do a couple more problems. Call it a day. So here's one. 9 plus 5 to the third minus bracket 4 times the quantity 9 plus 3, end the bracket. Write my order of operations to the right. Now remember, we do parentheses first, and we want to look for the innermost grouping. So that's going to be right here. Notice I do have brackets, but inside the brackets, I have a set of parentheses. And brackets are only used so we can keep things nice and neat. So I rewrite everything exactly how it looks. So we have 9 plus 5 to the third minus a bracket sign, 4. Now 9 plus 3 is going to be 12. Then I end the bracket. Now I still have math that I need to do inside the brackets. It's going to be this, 4 times 12. So 9 plus 5 to the third minus 4 times 12 is going to be 48. And now I'm finally done with brackets. Or parentheses, if you want to call grouping symbols, that's fine. In fact, now that we only have one number inside that bracket, if you wanted to, you could just put parentheses if you want. Now I got to worry about exponents. Well, I do have 5 to the third. So remember, 5 to the third means 5 times 5 times 5. And that's equal to 125. I'll let you do the math on that. So we have 9 plus 125 minus 48. And if you notice, I did not write the parentheses around the 48, and that's because it's just one number. That's it. So I don't have to worry about it. So now I'm done with exponents. There are no multiplication nor division. So the only thing I have to do here is just add or subtract. So let's go from left to right. 9 plus 25 is 134. And now I just need to subtract 134 minus 48. And that gives us 86 for a final answer. As long as you follow the order of operations, it does not matter what problem I give you. Okay? It doesn't matter what problem I give you. You will always get the correct answer, provided your math is correct. The order of operations is the recipe on how to simplify. So this is going to be it for this section. I'm going to just make another video for section 2. So I'll see you in that one. Have a good day. Bye.